In the first episode of this series, I share with you the project that I want to implement. I went through the initial planning and presented you with a selection of development kit boards that would be suitable for this project. You can find more information if you scan the QR in this image or just type the URL. In this episode, I will implement Bluetooth Low Energy, BLE, in one or more of the boards. Since this is a proof of concept, what I plan to do is, as soon as I am moderately successful in one of the implementations, I will move forward and go to the next step of this project, which is going to be developing the central part, the client of this BLE communication. Let's talk about some concepts, and let's differentiate Bluetooth Classic versus Bluetooth Low Energy. Although we refer to Bluetooth as if it were a single technology, in reality, Bluetooth Low Energy and Bluetooth Classic are two different beasts. The Bluetooth transfer rate of Bluetooth Classic is higher than Bluetooth Low Energy, 3 megabytes versus 2 megabytes per second. But as Spider-Man used to say, with great transfer rate comes great power consumption. And hence the profiles, the abstractions that we define for the usage of Bluetooth Classic are usually oriented towards continuously streaming data, like the ones used by audio headphones or hands-free speaking device, or even file transfer applications. On the other hand, Bluetooth Low Energy provides the ability to connect using different network topologies and allows for a lower latency, which makes it very suitable for IoT applications, healthcare applications, or even beacons or tags that can be used benefiting from these different network topologies. In this series, we're going to use Bluetooth Low Energy. In contrast with Wi-Fi and TCP/IP, Bluetooth is much more specific on the requirements for usage and also on how data should be encoded and decoded. This amount of definition makes it easier for devices from different vendors to interoperate with each other. However, that also means that the developer must go through the specs, understand the requirements, and have an excellent test suite. The data exposed in Bluetooth Low Energy is organized into attributes, which are the information atom, the building block of this technology. Each attribute has a predefined 16-bit UUID in case it is a SIG-adopted attribute, or a 128-bit UUID in case it is a custom one. Actually, the 16-bit UUIDs are just a way to refer to longer 128-bit UUIDs in which the rest of the bits are constant and are reserved for the Bluetooth special interest group. Within a server, an attribute also has a handle, which is a number that uniquely identifies the attribute for that type of server. It also may have permissions, which define whether the attribute can be read, written, notified, and/or indicated, and also the security levels for those operations to take place. The attribute protocol, referred as ATT, defines how attributes are represented and transferred. In our case, the noise level measurements are going to be using a predefined attribute. That attribute is going to have a handle that it will depend on the order in which this attribute is defined with respect to others in the same Bluetooth server, and it will have permissions that will allow us to read the noise level measurements, also to be notified about them, but no matter how hard we try, we cannot write the noise level measurement. The attributes are organized hierarchically, and they are described using the attribute protocol that I was mentioning before. Once a device can see another, the generic access profile is used to exchange these attributes and expose the functionalities and the way a device can interoperate with another. This information is exposed hierarchically, as I was mentioning before, and the higher level of abstraction would be the profile. Then we will have a service, then a characteristic, and finally a descriptor. Profile is a communication functionality that the device may have, and is composed of one or more services, and you can assimilate that to a use case. A service is a group of characteristics that are somehow related, and a server can have one or more characteristics. A characteristic is the piece of data, the data element that we are exposing from the Bluetooth Low Energy server. And the descriptors are metadata around those characteristics. So you can say things like, I want you to notify me if the value of this characteristic is above this threshold. So that information, the condition for the notification, would be stored in a descriptor. The generic access profile is responsible for advertising the device and controlling the communications. That advertising is done through either the advertising data payload or through the scan response payload. The first one is mandatory and is done at regular intervals, while the second one is just a reply to a request from the scanning device. In any case, we will be using the general access profile to define the roles of the Bluetooth Low Energy devices. There are 4 roles for Bluetooth Low Energy, and any given device can operate in more than one of these modes. The 4 modes are broadcaster, observer, peripheral, and central. A broadcaster is a device that is broadcasting but is not expecting to receive any connections. An observer is the counterpart of a broadcaster. It listens for broadcasts but is not going to connect to the devices that offer it. A peripheral, instead, is a device that is advertising itself and listens for connections, and once it is connected, it acts as a server. Then we have the central, which is the counterpart to the peripheral. It is scanning for devices that offer the service that it's looking for, and then connects to them and operates as a client. Let me elaborate on the responsibilities of the servers and the clients in Bluetooth Low Energy. Server is exposing data that it controls or contains to any other device. It does so by accepting commands and requests, and it sends notifications or indications to the requesting device. In our case, the MCU boards will be acting as sensors, and as such, they will be exposing the data of the noise level measurements to any other device that requests them. The client requests data using commands, and it also accepts notifications after requesting them, or indications. In our case, the collecting station will act as a client and will receive data from the MCU boards, the sensors, about the noise measurement levels. I am going to start with the Raspberry Pi Pico, and I'm going to use MicroPython for my first attempt. I will be trying to implement Bluetooth Low Energy peripheral in the Raspberry Pi Pico board, and I will be reading data from my microphone and exposing it through the BLE connection. Before we do any typing at all, let me talk a little bit about the development environment that we're going to use. I plan to use MicroPython, as I just said, and in order to do that, I need to flash it into the Raspberry Pi Pico board. I'm going to use USB flashing format in order to do that. It is also known as UF2. UF2 was a contribution done by Microsoft that helps a lot in order to flash boards like this one. It sets the board in a mode in which emulates a storing device. You can then drop a file in a specific format, a UF2 format, that contains the firmware plus some redundancy and some metadata. Then the device reads these through the bootloader and verifies that everything is okay and flashes the data into the board itself so it can be used as the firmware once it is booted again. In the case of the Raspberry Pi Pico, installing the new firmware is very easy. You just have to press and hold the boot cell button of the board while it is disconnected from the computer. Then you plug the board to the computer, holding the boot cell button, and a new device will appear that is going to be called RPI-RP2. You drop the file into this device, the file that is containing the latest version of MicroPython, that you have the link here in the notes, and the device will automatically reboot and have the new firmware installed. As I said in the first episode of this series, I'm going to use Visual Studio Code. And in order to interoperate with the Raspberry Pi Pico, I'm going to use the MicroPyco extension. If you plan to install this extension, I recommend you to create a profile in Visual Studio Code because it will allow you to switch between one board and another, disabling or enabling extensions that are required for one board or the other. That is very practical and also allows you to have the requirements for Python installed in this profile. In this episode, we are only going to implement the Bluetooth Low Energy peripheral part of the connection. That means that we need some application to act as BLE central and connect to our device and verify that everything is working as expected. In this case, we're going to use NRF Connect for Mobile, which is an application that is available for free both for iOS and Android. But you can use also others like Blue, which even allows you to connect from your Mac, also Android and iOS devices. You have the links for each of these applications in the notes of this episode. So let's start now with the code. There are two files that have a special meaning for MicroPython. Those are boot.py and main.py. You need one or the other or both in order to run any code at all in your microcontroller. The meaning of the boot.py is to store configuration. It is harder to stop, but this is where you put things that are required to run only once at the beginning when you start a board. The other file, main.py, contains the main application, the main thing that you want your microcontroller to do. And as such, it runs, unless explicitly configured, in a loop. and it continuously goes through the code that you have there.
So this is the Visual Studio Code, and this is the extension that I was mentioning before that we are going to use in order to share code with the Raspberry Pi Pico. In this first part of the code, we are going to make the LED, the onboard LED, blink. And what we are going to do in order to have that is to create a main.py file and import the machine module, actually just the pin object from it. So let's start by creating a file. So let me close this. Let's create a file here. And we're going to call this file main.py. Now that I have this file created for me, let me hide the side panel. And I'm going to add this machine module, actually just the pin part. The next thing that I want to do is to use this pin in order to have an instance of the pin that is connected to the onboard LED. So I'm going to do this by making LED equals pin and this string, which is in this board, assigned to the LED that is on board. I'm going to define the pin as pin out because I want to write to it in order to enable or disable the LED. Next, I'm going to create some loop, which is going to be toggling the pin and hence lighting or stopping the light of the LED. And I would also like to have here another module, which is time, because I plan to use here a delay. I want to make it be on for 500 milliseconds, half second, and off for the next 500 ones. So I'm going to just type here time.sleep milliseconds 500. That should be more than enough in order to get this to run. But in order to make this project be able to communicate with the board, I need to bring the palette and use MicroPyco configure project. So I'm going to use this one here, and I'm going to run this on the Pico. But before I do that, let me switch the camera so you can see the board here. There's no blinking at all. Then I run the code, and now we have the LED blinking.
Let's now go with some measurements. Our device is meant to measure the noise level from the environment. But since the MicroPython doesn't have a microphone in the board, we're going to start by measuring just temperature. We will change that to be noise level in the future. Temperature like everybody else.
In this part of the code, we are going to read the measurement of the temperature sensor that is installed on board. So the first thing that we need to do that is to add another module, another object for the machine module, that is the analog digital converter. So I'm going to do this here, and instead of having the two, I'm going to just add a comma here and remove the rest, and now I can use it. I'm going to create a variable that is pointing to another instance, in this case of the analog digital converter. So that will be ADC equals ADC4, which is the fifth analog digital converter, which in the case of the Raspberry Pi Pico, it's connected to the temperature sensor. And now I can read that. The measurement in this case comes as a 16-bit number, which I'm planning to use here, but I need to convert it into a temperature. So I need to use this formula that I have here that comes directly from the Raspberry Pi Pico documentation. It transforms the data into a 16-bit number and multiplies by 3.3, which is the voltage that is reading, and then that is a transformation from the voltage to a temperature. Finally, I would like to know that the temperature is being measured, and in order to do that, what I'm going to do is to print it on screen, in this case on the console. So that's done. Now I'm going to run this code, and yeah, I'm getting some measurements. So I'm getting these values here, and the LED should still be blinking here, as you can see.
Now that we have some measurements, we're going to develop the BLE peripheral part. And in order to do that, we can use the Bluetooth module that is a lower level module provided by MicroPython, or the AIO BLE, which is another module that operates at a higher level and is recommended by the MicroPython community. I like the second one better, but the documentation is a little bit lacking. So bear with me in order to go through the examples. We're going to start slowly, and we will be advertising the device using the GAP, the generic access profile, and that will share only attributes that are characteristics that are only regarding the description of our device, like the serial number or the name of the device.
The next thing that we are going to do is to implement the Bluetooth peripheral part. So this is going to be a BLE, and in order to do that, we are going to use the modules that I was mentioning before. So let me start by importing them, and sorry about that. This is going to be the AIO BLE and the Bluetooth module. The first one is the one that takes care of defining the services, defining the characteristics, registering them, even advertising the service. So it is the one that pulls most of the weight for this task. The second one, although I mentioned that it is not recommended for defining BLE services by the MicroPython community because it is a lower level module, we're still going to need this one because we're going to use the functionality that transforms a 16-bit UUID into a 128-bit UUID. Now that we have those here, I'm going to define a constant here that is going to be the service that we're going to create. In this case, we're going to go with one of the predefined SIG reserved numbers. So this is going to be 180A, and this is a device info by the Bluetooth standard, a device info service. That number can be used together with the AIOBLE module, and we can then register the service. Let me go to the beginning and try to delete the mistake here. And this service just uses the UUID that I have just created. Okay, so the purpose of this service is to present the user with information about the device itself, about characteristics like the name of the device or the manufacturer and so on. So in order to have a few of those, I'm going to define some constants here that are going to be referring to the manufacturer name, the model number, and so on, and are also going to be using the predefined numbers for these UUIDs, these 16-bit UUIDs that are going to be transforming to the corresponding 128 bits. I'm going to use those with the service definition in order to create a characteristic for each one of them. As you can see here, I'm attaching in the attribute structure, in the attribute hierarchy, these characteristics to the service that I have just defined. And then I use the UUIDs. I make all of them read-only because these are not going to be changing. And I provide some initial value that is going to be the value for the rest of the application. So, for example, for the manufacturer name, I'm going to use Jorge as the initial value. Here I could use things like notify me or enable notifications, enable writing, but in this case it makes no sense at all. Now that I have defined the service and some characteristics, what I want to do is to register this service. And I'm going to do so by using the AIO BLE module again and the definition that I have just created. With this, I have the attribute structure that I want to use for my BLE peripheral device. What do I do next? Well, the thing that I would like to do next is to advertise this service. But before I do that, I'm going to import a functionality from MicroPython that is going to be the constant one. And I'm going to use that functionality in order to define two constants. The first one is going to be this interval, which is in microseconds, and is how often we send the advertising payload. And the second one is how we want this device to be shown to the rest of the world. And we are going to do it by showing it as a multi-sensor device. Now that I have these two, I'm going to create a new function that is going to be taking care of the task of advertising this device. So we create this function here, and the function, as you can see, has basically an infinite loop, and it uses the advertise. It also handles the connection. So this is the general attribute protocol that general attribute profile that I was mentioning before, that takes care of advertising and handling the connections. And it waits till the connection is disconnected and starts again. It starts advertising. It doesn't advertise while it is connected, but then we can continue this loop forever. Okay, so now that I have defined that, I would like to also be able to operate on the basis of knowing when things are connected. So I'm going to define a variable here that is going to be the status of this device, whether it's connected or not. And I'm going to have this exposed to this function so I can change it from here. And every time I start the loop, I'm going to set it to false because at this moment in time, I know that there's no connection available. But when I get to the connection part here, I obviously going to change that to connected true. So by doing these three things, I know now that the status is either false or true, showing me whether the device is connected or not to another device. Good. Now I'm going to go with another task that I would like to perform at the same time. So this task is going to be the one that is going to be responsible for blinking the LED. And I'm going to add this task here, and this is going to be slightly different from what we had before. In this task, notice that I have two different delays, and I use one or the other based on whether I'm connected or not. So what I will have here is that if the device is connected, then I will be blinking slowly. But if it is not, then I will be blinking this LED faster. The thing that I would like to add here is that I'm awaiting, but I don't want to have this blocking for this delay. And in order to do that, I need to use the async IO sleep method. And I need to add this async IO as a module here. So let me go to the beginning of the program. And what I'm going to do here is add this import U async IO. This U is for the MicroPython implementation, but we're going to use it as the regular async IO that is available for general Python. Now that I have that, that shouldn't be an issue here because I have this sleep underscore ms available. And this is the second task that I wanted to have. I'm going to add a third task here that is going to be this one. And this is going to hold the data, the information related to the sensor that I was capturing here before. But notice that I have defined this in a way that I can reuse it later. So let me use this as a constant. So let's put this here. This constant is going to be the interval in milliseconds that will be happening between one measurement and the next. And this sensor is basically moving the data that I used to have here, the main loop, into this new task. But notice that the delay that I have here is a blocking one. So I would like to replace that one with a non-blocking delay and obviously get rid of the other one here. And also the thing that I had before about the sensor. So I have three tasks here, one for advertising the peripheral and connecting to other devices, one for blinking the LED, and another one for measuring the temperature from the onboard temperature sensor. So what do I need more beside that? So I need another function that is going to be the main function that is going to spawn each of these tasks, the peripheral task, the flash LED, and the sensor task, and is going to make them run concurrently and wait for them. Obviously, none of them is going to end because each one of them has an infinite loop, but we want to run them concurrently, and this is what we are doing here. Finally, in order to be sure that everything here runs in the main program, I need to add an invocation as part of the async IO of this main function that I have done. So now I have an asynchronous context that allows me to run main asynchronously and then do the await that I have inside. So let's run the code that we have just created. And as you can see here on the top right, we have the Raspberry Pi Pico. So let's run the code in the Raspberry Pi Pico. And as you can see, the temperature is showing here, and we have a fast blinking LED. So the other thing that I would like to show you is that in my mobile phone, I'm having, let me try to scan again, I'm having this device shown here. So I have this EP2 sensor that I defined before, and I can connect to it. While I am not connected to it, the device is blinking fast. Let me move this a little bit to the left. But when I connect to it, you will see that, let me make the connection, and you will see that it starts blinking slowly now. And it shows the information that I define as attributes and characteristics here. So I have this information here that contains basically the data that I defined before. For example, here I have the model number string, the serial number string, firmware revision, hardware revision, manufacturer name string. Let's try to use this here to pull the data, and I get the value. It's Jorge. So it seems that it is perfectly working now, and as I disconnect from here, you will see that it starts blinking fast again. So that's basically it.
Our device is now scannable, and we would like to add some real data to it. So we're going to add a new service that is going to be able to provide the measurements of the temperature that we already have.
Let's modify our Bluetooth low energy device in a way that it provides data that changes. So at this moment, we are using a single service in our Bluetooth low energy device. That is the device info service. And it provides data like the manufacturer name and the device serial number and so on. We want to have a second service defined here, and in order to have this second service, we are going to start by defining the UUID of this service. That is going to be also a SIG adapted UUID that is going to be the one for the environmental sensing service. This is also part of the standard, and we are going to use it here to define a second service in the same way that we did with the service device info. So here we're going to define a second service that is going to be the environmental sensing service. Well, so we have this second service, but it is going to be completely worthless unless we define at least one characteristic that is added to that service. So we're going to add the temperature measurement, which is one of the possibilities for having some temperature characteristic in the environmental sensing service. And here I decided to go with this one. It could be any of the others, but that was making more sense to me. So the important thing here is that you attach this characteristic to the service, and we define in this case the temperature characteristic. Notice that I have kept the result of that in a variable because I'm going to use it later on to write to the characteristic, and I am defining it in the same way that I was doing with the other ones, but I have no initial value. It is readable, it contains the UUID for the SIG adapted number, and it is related to the service as it was the case before. Now that I have the characteristic and the service defined, I need to register not just this device info service, but both of them. So I'm going to do this by changing the registration in a way that it uses both services. Perfect. Besides that, I need to do another change so the data gets advertised here. And that would be in the peripheral part here in the general attribute profile that is only advertising the service device info here. So I need to go from here and replace this one with the same invocation bed with both UUIDs. Now I have the second service also advertised. Let's make it do something useful. And in order to make it do something useful, which is sending making it available, the temperature. So the thing that I would like to do first is to create an auxiliary function. This function is going to help me to encode the data as it is required by the Bluetooth standard. And this is a format that is the IEEE 11073, which I didn't know before I started creating this code, but that's basically encoding the integer part of the number in one side and then holding the precision for the mantissa in a different part. So it dedicates 3 bytes, as you can see here, for the integer part and 1 for the number of digits that you have in the floating part. So the only thing here is that it is complaining about this true, and this is because it's looking at the format of this 2 bytes function from the integer object, which is perfectly fine for MicroPython, but it would be completely different for traditional Python. But the thing that we should solve here is that we are not importing a struct. So let's go to the beginning of this code and let's remove the time that we don't need anymore, and let's import struct. Okay, so that's basically what we needed here. Now our function shouldn't be complaining anymore, and we need to use this function and the characteristic in order to send data when required. And we're going to do that in the sensor task. So here, after reading the temperature, we can send the data to the Bluetooth low energy stack. And we're going to do that by adding an invocation to the right method of the temperature characteristic. And we will be encoding not just this number, but this 0 here, which is a single byte little endian. And that means that this temperature is measured in centigrades rather than Fahrenheit, and that there's no timestamp attached to this measurement. We could add a timestamp, but I decided not to do so. So that's basically all we needed to do for having some value provided here, but I would like to make a small change in the code so it doesn't stop the connection after 60 seconds. The thing here is that if you don't provide any timeout here, the default timeout is 60 seconds. So I'm going to replace this one by another timeout that says that it's none. So it won't. It will wait there indefinitely until the connection is closed by the other side. So now that we have the code, let's try it. We're going to start by running the code in the Raspberry Pi Pico. So I stop it, I rest it just in case, and I run it. And here I'm going to rescan for devices. So let me scan here again. And when I connect to this device here, we will see that there's additional data that we didn't have before. So we are going to have this environmental sensing data here at the bottom, and it has a temperature measurement that it has identified properly. Now, if I tap on the down arrow here of this characteristic, it will be asking for a measurement, and it provides this value, this 39,68 centigrades, which is it was the value that was there on the screen on the console right before. And don't be scared, this is not the temperature in my environment, but this is an onboard temperature sensor, which means that it's a little bit hotter than the environment around me. But the thing is that it's measuring the data properly, and that we have this data sent through Bluetooth to our application.
The GATT specification supplement, which is a book that you need to print and keep under your pillow, states that if you want to support notifications, you need to implement the client characteristic configuration attribute in order to enable these notifications or disable them. Then you need to have an ES trigger that will provide configuration about when these notifications are expected to be sent. If the value exceeds a threshold, every interval, or any other condition that you want to set for the notifications. You can have more than one ES trigger, 2 or even 3. 3 is the maximum. But if you do so, then you need to configure whether you want these conditions to be operated with an AND logic or an OR logic. In any case, we will need to have like a very basic structure in order to provide these notifications to the client. Also, you have to keep in mind that in order to change the values of these descriptors, you need to be binding. That means persisting pairing. So you can change the ES trigger setting and the ES configuration. All these things are a lot of work for a proof of concept. So here I'm only going to notify every time independently of the condition and the trigger. We're going to repeatedly notify after some interval. I know that I'm cutting corners here, and let me be clear. This is not the way it should be. However, it is my understanding that this implementation is good enough to understand the viability of this device, of this project. So this is what we are going to do for this proof of concept.
Let's change the code in a way that we can use this same characteristic, the temperature measurement, but in a way that it sends notifications, not just when it is requested, but all of the time. So that is not exactly how it should be implemented, but in this case, we are going to simplify the code here. The first thing that we are going to do is to go to the place where we were defining the characteristic. So that would be here. And we are going to replace this definition of the characteristic with one that is exactly the same, but has the notify equals true attribute, this argument, to indicate that we would like to send notifications, that we are available for sending notifications to the BLE central devices that connect to us. Now that I have that, I will need to, according to the standard, to implement a descriptor that will tell my device whether notification should be sent based on some conditions. I'm not going to honor the conditions. I'm going to basically ignore them. But at the very least, I'm going to show that I have this descriptor available for the BLE central that connects to us. So I'm going to define the UUID for this descriptor, which is the descriptor that is called environmental sensing trigger setting. And that's also part of the SIG adapted numbers. And I'm going to attach that descriptor to the characteristic that I have previously defined. The descriptor, the way we define a descriptor is exactly the same way that we used to define a characteristic, but instead of attaching it to a service, we attach it to the characteristic, that is the hierarchy that we should follow. We use the UUID, we allow to write to this descriptor, and we provide some initial value that in this case is going to be 0. That is all we need for the descriptor, and basically now we can use this code in order to run the measurement. So what we are going to do in order to send a notification is to use the connection that we receive as part of our advertising and connection handling part. So we need to have this connection available for the sensor task. We do that by creating a variable here that is going to be the connection, and that is going to be initially set to none, and we are going to expose this connection here in a way that we can modify it from inside of this function, but at the same time making it available for other tasks to be able to use it. So we are going to expose the connection here, and we are going to ensure that when we disconnect from a device, we set this to none again. So we are going to set connection to none here. Okay, so that's basically it. When somebody connects to us, we will have the actual value of the connection. When they disconnect from us, then we will have it set to none. Now that we have an actual value for the connection, we can use it. And then we can go to the sensor task here that we had. And let me move this here. Let's paste this code here. And we are going to basically do the same thing that we were doing before. In this case, because I'm going to send the data twice, I keep it in the variable that is called payload. And if the connection is available, then I'm going to use the notify method of the characteristic to send the data to it. Obviously, I don't need this thing anymore because it's basically the same thing that is happening in line 80. So what I'm going to do is I'm going to delete this line. And that's basically it. I'm sending notifications all of the time. Let's try it. So let's see this in action in my device. I'm going to run the code in the Raspberry Pi Pico, and let's stop it and run it again just to be sure. So we run this in the device, and we are going to scan again for devices. We have the EP2 sensor here, and we connect to it. It is querying the general attribute profile about the services and all the hierarchy of attributes that I have here. And notice that at the bottom of this, I have the temperature measurement. But not only that, I have a client characteristic configuration, which I haven't defined. This is a descriptor that is added when you add notifications, and the environmental sensing trigger setting, which was the descriptor that I attached here. And notice that in the temperature measurement one, now I have two down arrows here at the right. One is for reading, the other one is for continuously reading notifications. So I'm going to tap on the second one, and hopefully I will be getting data for each update that happens about the temperature. So now I'm getting this data here, and it is shown immediately in the application. I can disconnect from notifications and ignore them, but in this case it's completely unnecessary. So it seems that it works perfectly fine, and we're done.
In this episode, we have implemented the BLE